So here we are preparing for the chapter 32 review here. And, when you look at the words that we've gone through so far in the chapter, you've got charge, conductor, conservation, charge, coulombs, Coulomb's law, electrical force, electrically polarized, electrostatics, grounding, induced induction, insulator, semiconductor, and superconductor. And, it's not a big chapter, but it's very important to the science that is electricity. So let's go through step by step, going through these review questions. So here we are with number one. What force, gravitational or electrical, repels as well as attracts? Well, I don't know about you. I have never noticed gravity to repel anything. Gravity always seems to attract things. So gravity is certainly going to be the one that attracts. But we talked about how with electrical forces, how there's a repulsion between like charges and an attraction between different charges. So moving on to number 2. Gravitational force depends on the property called mass. What comparable property underlies electrical forces? That's going to be charge. Charge is the physical property that we're going to be spending a lot of time talking about. So speaking about charge, how do protons and electrons differ in their electrical charge? Well, hopefully you've retained this one idea from chemistry, that protons are positive and electrons are negative. And the next question is, how does the size of their charge compare? I know that's not question 3. I'm saying it goes along with it. The size of an electron and the size of a proton's charge are identical in size individually. So then next here, is an electron in a hydrogen atom the same as an electron in a uranium atom? And the answer is yes, absolutely. One of the fundamental things of science that we know is that in the universe, so far as we know, every electron is identical. Now, they couple differently, they get together differently with the atoms. Your hydrogen's got 1, your helium's got 2, that sort of thing. But so far as we know, every electron in the universe is the same. And that leads to the next question. Which has more mass, the proton or the electron? There is a considerable size difference between protons and electrons in size. If you want to make a comparison, imagine a basketball that's solid compared to a pea. That's proton to electron. Protons are very much bigger than electrons, and yet their charge is the same. So, moving on to number 6 here. In a normal atom, how many electrons are there compared to protons? Well, in a normal atom, these two things are equal. Go back to when you were learning about the periodic table and what the numbers meant. When you look at good old oxygen, it's number 8. Theoretically, your oxygen will have 8 protons and 8 electrons. Just straight up 8 and 8. So in a normal atom, those two are equal to one another. Next question. How do like charges behave? Well, like things repel, and unlike charges attract. Next question. How does a negative ion differ from a positive ion? Well, then you got to remember what an ion is. An ion is a charged particle. And when you think back to what you learned about ions and when you're learning about bonding, you said, oh, hydrogen likes to form a negative ion, or a positive ion, whereas something more like fluorine or chlorine likes to form a negative ion. Why is that? Well, fluorine and chlorine like to steal an electron, giving them extra electrons, making them negative. And hydrogen's very willing to give up its electron, making it more positive. So how are positive and negative different? It's the number of electrons they have. Negative ions have extra electrons, and positive ions have fewer electrons. Next. If electrons are rubbed from a cat's fur onto a rubber rod, Does the rod become positive or negatively charged? Well, if the electrons are going from the cat's fur onto the rod, well, the rod is becoming negative because it has extra negative charges. What about the cat's fur? Well, the cat's fur would have to, in turn, become positive. If the rod is becoming negative, the fur would have to become positive. If you, a combination that you could use in class would be a wool sweater and a rubber balloon. If the rubber balloon steals electrons from the wool sweater, that means that the balloon becomes negative and the sweater becomes positive. And let's just say you could build up a ginormous 1 coulomb charge. If the balloon has a negative 1 charge, that means that the sweater would have a positive 1 charge because it stole from them. That goes back to this whole conservation of charge thing. And that leads into number 10. What does it mean to say that charge is conserved? Well, it means the charge is not created or destroyed. It just changes forms. Well, that's not even the best way to say it. Charge is neither created or destroyed. It just changes places. You can't create electrons. You just move them around. So, again, going back to chemistry, if you join sodium and chlorine, Na and Cl, those electrons that bind them together aren't going away. They're not being destroyed or created. They're just sharing the two of them. Well, same thing happens here with electricity. When you turn the light switch on, you're not creating electrons to go through the circuit. You're just moving electrons that are already in the circuit. Next, number 11. How is Coulomb's law similar to Newton's law of gravitation? And actually, I'm going to flip back into the chapter here to talk about this one because there's a nice illustration here in the chapter about it. Okay, I gotta go back farther, sorry. One more, right? Here we are. Here we are. So, I mean, kind of there. Got rid of the glare. Look in here. Gravity. Force, gravitational constant, mass, distance squared. Electric force. Force, Coulomb's constant, charge, distance squared. They are both inverse square laws. That's how they're similar. The form of the equation is similar. You're multiplying two masses, you're multiplying two charges. You have a multiplier there. How are they different? G in gravity has a very small magnitude, whereas K in electricity has a huge magnitude. Okay, look right up here. 9 billion. 9 billion newtons per coulomb. Newton meter squared over coulomb squared. Versus with gravity, it's 6.6 and 10 to the negative 11th, which is teeny tiny comparatively. Okay? Gravity is by far weaker than electricity in this regard. Back to the questions here. So, I'm kind of answering some of the other questions as I go along, so please forgive redundancy, but that's just how it is. Here we are with 12. The SI unit of mass is the kilogram. What is the SI unit of charge? Well, that's the Coulomb, named after Charles Coulomb, Coulomb's law. And then that leads right into number 13 here. The proportionality constant K in Coulomb's law is huge in ordinary units, whereas the proportionality constant G in Newton's law of gravitation is tiny. What does this mean in terms of relative strength of the two forces? It means that electric forces are way stronger than our gravitational forces. That's why we talked about in the bell work how gravitational force is very weak compared to electric forces. And gravitational forces do not hold the universe together. They hold planets in orbit, but they don't hold matter together. So, next. Why does the weaker force of gravity dominate over electrical forces for astronomical objects? Meaning things like the sun and the moon and the stars. Well, because they're so big. And also, electrical forces are very good when you're talking about charged objects, but the moon and the sun and the stars aren't charged. Alright, number 15. Number 15. Why do electrical forces dominate with atoms? Well, atoms, number one, are very close together. That helps. They're very close together, and they're charged up. You're talking about electrons and protons interacting with one another. What is the difference between a good conductor and a good insulator? Conductors allow their electrons to move freely, whereas insulators have tightly bound electrons that do not allow them to move freely. Why are metals such good conductors? Again, right like 16, because metals allow their electrons to move around freely. Why are materials such as rubber and glass such a good insulator? Again,